Hey guys, welcome back to my channel. This is Ankit and you're watching Mahadev. So this video is a second part of our 3D rocket game series. Do check out our first part if you haven't watched, where we build this rocket and smoke effect. So let's start with rocket control and collision effect. Yeah, so we'll start with reducing the size of our rocket. Yeah, this side is good for our game. So now let's go down and create a logic for controlling our rocket. Let's bring this code here. Yes, this would be our rocket body. Now we'll make the control mechanism. So we will listen to the key presses from our keyboard, receive the event E, and inside the callback we will check if the key code is for left button. So you can see the key codes on the screen. We'll create a control object which will store false initially for all our keys. So for each key press we will change the respective object key to true. Yeah, so this is it. Now we'll copy this code and we'll do the same for key up. In this we will make all of these false. Yeah, so now inside animate we can create our function update rocket position. Yeah, so let's create our update function. Now depending upon the object values, if the control dot up is pressed down, we will update the rocket mesh position along x-axis. Same we will do for down, left and right. Yep. This will be minus, this y plus and y minus. Yep, all good. Now let's collapse all these codes and now rotate our rocket to at an angle. So that's why our options were a bit jumbled up, you must be thinking, because we will keep a constant x rotation and y rotation. So you can see this, it's just rotating now. We need to remove. Yeah, so it's jumping too much. I guess the value is too high for up, down, left and right. Let's make it a smaller value. Yep, so this is a lot better, but still we have a problem. Our rocket can go out of the screen. Yep, for all the directions. So we need to restrict. So what we will do, if our rocket position is greater than the window's inner height along y-axis, we will check divided by 160. 160 is the value I found out, which corresponds to my limit. So same we will do along x-axis. Yeah, so this will be x, and instead of height this would be width. Same goes for all. Just make this less than, and x. This should stop our rocket from going out of the screen. You can see it limits to the corners. We can also check on smaller screens. It auto positions itself to the corner. Yep. So that's done. It's now just looking like a model moving. So let's add our animation to our rocket mesh. So when we press left button, we'll give it a angular tilt. Now let's check out. So you can see the angle at which it turns. This much angle or bend is good. So we'll copy this code and paste it for right also. You can just change the direction in which it will bend. Let's give it ease of in out, or out is good. Yeah. So now let's copy this code and paste it for our up, and same goes for left. Just the value needs to be updated. Oh, just found this. This should be X, and down here too. Yep. So this was for key down. Now for key up, as soon as we releases the key, it should be auto position to the default angular tilt that we set. For Y that's 1.5, and for X that's minus 1.5. Same for up and left. So you can see the tilt. Press up and down, also along left and right. When we go left, you can see that angular tilt. Same for the right side. So now come the time to add our smoke back. So you can see that our smoke is starting from a fixed position and ending at a fixed position. So we need to make few changes in draw particle. It must start from our rocket's position. Yeah. So okay. So along one axis that's happening. It's starting. We also need to do it for the x-axis. We'll copy this code and set the initial x value for rocket's x position. Yeah. Let's check out. Yeah. Better. I guess we need to remove that -1 from there. Better. Okay. So it's coming from the tip. We want this from the back, right? So we need to increase the z index, so it starts from the back. Now let's make it z plus a smaller value. Let's check. Yeah, a lot better, but it's going downward. We want it straight along z index, so instead of y we'll make it z. So let's check now. Yes, this is perfect, but I want this to be a little downwards so that our rocket is visible even when the rocket is in center. So we will also give it the y value, not too large, just a smaller tilt to our smoke. Yeah, so you can see the angle that on which it's coming. But still you can see it's a bit misaligned. So I guess -0.1 would do the magic. Let's also reduce the smoke length to 3. Yep. So that's perfect, what we wanted. Now let's start with our obstacles. So let's get back to our code, create a file level, import our 3 and export our default class level, inside which we will create our mesh. This would be default 3.object 3D mesh. We'll create an empty array first to store the obstacle layers. Let's create our first box, regular box geometry, 6, 10 and 2. Same for box 2. Now create the material for box 1. 3 dot mesh form material, inside which we can pass our color, and also we will set the flat shading. Let's copy this for our box 2 material. Now let's create our final obstacle boxes inside our loop so that we can have multiple layer of our boxes. For now we'll keep 10 layers. Now let's generate a random number to set the position along each layer. Uh, so this would return random value between 1 to 10. We will start pushing our position. So let's create our first box, sending our geometry and material. Same for the box 2 we will do. Now we will set the position for these boxes. For box 1 we will use this random value along x-axis. Let's also set a few of the shadow properties so that our boxes can cast and receive shadow. I'll copy all these 3 lines for box 2, rename this. Yeah. This will be position minus 10. We'll now keep a fixed position along each layer, which would be randomly placed for each layer. So now for this layer we will create a new 3 object 3D, inside which we will add both of these boxes. Now in this layer we will position along z-axis, so we are iterating with I and we'll position it at a distance of 40. Now let's add this layer to our mesh. So let's import our level class from level.js file. Now down here we can create our obstacle below our rocket body. This will be our obstacle layer. Let's create a new level object. Let's add this, give it a position z of minus 40, so it starts from minus 40. Let's check how this looks. So all good, just we have same color, it's looking monotonous. Let's add a different color. Yeah, a lot better. Still we can't go forward and backward, so for now we will keep it in our hands to move the layer forward and backward. We'll create forward false and similarly backward false. Later we will make this automatic, it's just for testing now. Let's make this with W and S. For W we will forward the layer, and for S we will set backward to true. Let's copy this and put it in key up. We'll make it false. So if control dot forward and backward is true, we need to update the we will update the rocket position instead of the mesh. This will give us much advantage later. We'll reposition its z index for forward, now for backward minus. Let's check. Press up, forward, backward. Yeah, this is working fine. We can play the game, but we have a problem. Our obstacle are just an object. We have no collision effect. Yeah, so let's start building our check collision function. So this function would be the toughest thing. We'll make our own logic. So we'll iterate with the length of the layers that we have. We added the random positions into an array. So we will use that same array here. So because we know that each layer is placed at a distance of 40 40, so if our position is aligned to any of the layers, we are doing +1 and -1 because the axis goes through the object. We are just giving a buffer of 1 on each side. So if that is the case, we need to check if our rocket is in contact with any of the object. So now along x-axis we'll check if our rocket's position along x-axis is greater than the random value that we have. So here we'll have a buffer of 3. We are just adding 0.525 because we also have a width of our rocket. We are assuming it to be a 5, so 0.25 on each side. So this was for obstacle 1. Now let's make for obstacle 2. So each layer we have 2 obstacles, so we need to check for both of the obstacle for a particular layer. So because that was at a distance of 10, we have a distance, so we need to subtract 10 from each side. So now if we are inside this function, that means our rocket has collided. So for the effect, we can see our rocket is made up of multiple objects, each of which have sub-objects. So what we will do is we'll iterate over all its children. So for roof and its children, what we will do is we will create an animation effect using GSAP and position them to a random value along all the axes. So let's create, we will position them in correspondence to their original position. We will just add few random number. Same for y and z axis. Yeah. Same we will do for, this was for roof. Now we will, let's check body, window and base. Yeah. Body, here window, and here base. So that's good. Let's make this plus and minus so they go in different directions. Okay, it just vanished. Let's check again. Something's odd. Let's check. So we are adding this to nothing, the random value. We need to make this x, y, and z. Down we go y. Yep, here's z. Now this should work. Yeah, so it just went out of the screen. Now also we are able to move this again. Let's fix these issues. Let's first reduce this 1000 to 500 is good. Also all of them went to the same direction, so let's change this to minus. 500 is still larger. Let's change this to 50 for now. Let's check. 50 is too less. Let's make it 200. Yeah, so it's now going in all the direction, and 200 is okay for now. But still, the we can still control the rocket after collision. We need to stop that first. We'll declare has crashed as true here. Its default value in the global will set it to false. So now as soon as the rocket has crashed, certain things needs to be done, taken care of. We will not create smoke if the rocket has crashed, and we won't also update the rocket position if it has crashed. Yeah, that's obvious. If it's crashed, there is no control mechanism. Also, if it has crashed, we don't need to check the collision. So that's an iterative function. It's running all the time. So let's stop this function as soon as the rocket crashes. This is cool now. Let's check. Yeah, so that was a lot better. Now we can't control also. Let's increase this to 400. This will double up the crash effect. Yeah, a lot better. It's still tilting because that's in key down, I guess. Let's check. Yep. So we also need to restrict key downs if the rocket has crashed. Let's wrap up all for now. Yeah, that's good. Now let's start building the reset mechanism. So this will be outside our has crashed, because even if it has crashed, if we press R, we can reset our game. So the key code is 82, and here we will perform some animations. We will reposition our rocket over z index to the initial position, that is 0, all the values. Also, we need to update the levels z index to -40, and on complete we will make this false because our game has reset it. Let's check. Let's R. Okay, this should again recombine into one rocket. We can play along, and this breaks even more. This is fun. Okay, so now let's make our transition array. This is an empty array in the beginning, and inside crash, each gsap.to returns a twinning object. We will push this object into our transition array for all of these. So for each of the rocket's child element, we have one tuning node inside our transition array. Now what's need to be done is we will iterate over this array, and for each of this object we will call the reverse function. This should do the magic. Let's check. Press R. Yeah, you can see that cool animation, guys. So that's it for this video. So hope you guys enjoyed. See you again in the next part where we complete this game. Thank you all for watching, and do like, share and subscribe if you like the content.